The first thing what I'm going to point out is you see the little stack there, that little rocky island.
Oh,
that's stack fadder, and this tektite is in what's the stack fadder member. So you see it, and then there's a kind of band of harder rock sticking out into the sea, which almost reaches it and comes into the land. That's where we're going to walk to, and the path goes up behind that bench, and it comes sort of up and down along the coastline to get to there. It's quite tiring. It's not that bad. It's quite tiring, and the reason I'm just saying that is that's the whole reason for the walk, is to go there and to come back and to see what we saw in that centre yesterday. So if you're thinking you don't want to do it, you can just stay here. Other things I'm pointing out is on that headland there's actually the ruined remains of a broch, and a broch is an iron-aged castle, and you'll see those going to Shetland. You'll see more of those in Shetland, but it was actually built 2,000 years ago, and it would be a towered castle, and that's the remains of it.
And you can walk out there to it.
You can if you decide you don't want to see the deposit. You could actually go there instead, but make sure you're back at the bus at the time that I want us to be back at the bus.
There's a little path right there.
Yeah, you can, but a lot of it is walking on these sort of cobbles, but it's a shorter walk than going over there.
So here we are, Precambrian sandstone, but unlike the billion-year-old Torridon, this is 1.2 billion years old. So these are even older sandstones, and there's multiple unconformities here between the 1.2 billion and the 1 billion year, and of course the 1.2 is angular to the 3 billion year old gneiss.
I'll stop there. So
some truncation going on.
Oh yeah, that's all very interesting too. Wow. But if you come within earshot, this band of rock sticking out here is the stack fadder member. It contains all the glassy material that is initially considered to be volcanic, but recent reinterpretation saying no, it's from this meteor impact. And we're going to come down onto the level here to see it. But with this meteor impact, one thing we didn't say yesterday is they found this big gravity anomaly under Leg. They've also found what they think is another crater out there in this piece of water called the Minch, which has led some scientists to say, hang on, no, that wasn't the meteor crater, this was. But of course, there's another alternative as well. The meteor can break into two as it enters the atmosphere, and this has happened in many sites around the world before. So you can actually have two craters of the same age quite close to each other. Yeah. So there's no reason why they both can't be a crater. But what we're going to do is we'll have a little look at it in outcrop, to see it in outcrop. But it's kind of more spectacular to, after we've done it, to go down there to where the pebbles are, because you can actually collect some of these pebbles and take them with you. But it's nice to see it in outcrop too. And the outcrop is here. We're on the outcrop, so if we come down onto this surface, we can start to see the green glassy material in the mudstone. So
just a moment, because you must tell us a little bit about these truncations.
Please.
Well, I don't know much. And all the molten debris,
glass and debris,
which is a mixture of the melted rocket hit and a mixture of the original meteorite. It goes up into the air and it rains down into the mud here, and this is what this green glass is.
Does this qualify?
And when did that all happen?
1.2 billion years ago.
Wow.
And they saw shock in the glass that
They've seen that in the glass. They found iridium. They've also found, which is very rare mineral on this earth, but it's more common in meteorites. They also found zircon crystals, and within the zircon crystals there are little veins of, I forget the name of the mineral, but it's a shock mineral, only forms under extremely high pressures.
Stishovite?
It's not actually stishovite. The stishovite is a well-known mineral. But when we actually go on our Germany trip, there's a church. The green and the red's the same age.
So the rock here is 1.2 billion,
1.2 billion.
and the
This
green
meteor
crystals
hit
are possibly a
before,
billion,
and all that
result
rock
of a meteorite
covered it up.
impact where the
And
glass
this
came back
volcanic
down
glass, not
into
volcanic,
the
it's
into the
glass,
sediments.
which we
This piece of it.
Okay, so now which these dark
It's the dark green things there.
are the
Tactolite.
tactilites.
It's like a glass that fell down. It was melted.
Wow.
And here, look, you've got like a dike within the ice there.
Hey Linda, there's video down here.
Okay.
Linda S. It's a calibration of size.
So, don't follow me down. Okay. I want to find some of these ripples and cracks. I don't want you to come down and then I say it's the wrong place.
So this is the Torridonian Precambrian sandstone. And he's looking for mud cracks.
This is the 1.2 billion.
Okay, you want
But it's the surface. It's all got like lichen on it as well, and it's weathered. It is here. If you're looking, it's all over. If you look closely, some of the patches are lichen, but actually some of the patches are the pale greeny colour. This is it. But it is more convincing down in the pebbles on the beach. So we just have a quick look here, and then we'll go down onto the beach. Okay.
Yeah.